Alright guys, welcome back to Underground Science, and in this video, if you just came back from watching my video on the noble gas notation, right, we left off right here. I mean, there was more writing, but we said that we would continue off by by drawing the electron configuration orbitals out, and by talking about the Pauli Exclusion Principle and the Aufbau Principle. Alright, so let's go ahead and get started. Okay, so let's start again. We're working with the same three elements, right, that we did in the last video. So let's start with magnesium. Let's go ahead and draw magnesium's electron configuration notation out. So for that, let's go and refresh ourselves and write down the electron configuration for magnesium, right, which is 1s2, right? This time I should write the long way. So since we can see all the energy levels and orbitals, so 1s2, 2s2, 2p6, and 3s2. Okay, so let's go and draw that. So here's how you draw. So first you start from the lower energy level and you work your way up to the top, or to the highest energy level. So 1, so the energy level of 1, which will start right here. So this will represent our 1s orbital. And in our 1s orbital, if you go and look, we have an exponent of 2. So what does that mean? In our 1s orbital, we fit 2 electrons. And the way you draw the 2 electrons are a positive 1/2 spin quantum number and a negative 1/2 spin quantum number, right? So you just draw 1 electron pointing up and 1 electron pointing down, all right? And then we're done with our 1s. Then we go ahead and draw our 2s orbital. And we draw above our 1s orbital because our 2s orbital is our second energy level, or our second principal quantum number, and our second energy level has more energy than our first energy level, which is our 1s. And we're still in the s orbital, so we just draw it directly above. And again, if you go and look, we have 2 electrons in our 2s orbital. So again, we draw 1 electron pointing up with a positive 1/2 spin quantum number, and 1 electron pointing down with a negative 1/2 spin quantum number. All right, and next we go ahead and draw our 2p6 orbital. Okay, remember from our quantum number videos, we said that the p orbital in total has 3 different orientations, 3 different p subshells on a 3D plane, a px and a py and a pz. Okay, so we have a px, a py orbital, and a pz orbital. Right, so let me go and write to be consistent. 2px orbital, we have a 2py orbital, and we have a 2pz orbital. Okay, so actually let me go and write that neater. So we have a 2pz orbital, so an xyz. Okay, and each orbital, remember we said each subshell can fit 2 electrons, and here we see we have 6 electrons in our 2p orbital. So we're going to have 2 electrons in each orbital, right? So because 2 times 3 is 6. So again, we draw it the same way, except this time you have to make sure to follow. Actually, you know what? While we're at it, right? Let's just go ahead and add to this title. Sorry about that. Add to this title. We'll also be covering the Hund's rule. All right. Sorry about that. Supposed to put that first. All right, the Hund's rule, and we're going to talk about that right now. So because we have 3 different subshells, right, 3 different p orbital subshells, you're not supposed to put the electron like here. So when you draw, right, we have 6 electrons total to draw. So 1. Now you don't do 2 and you don't move on after here. Okay, essentially at the end it's going to be the same thing, but later on we'll see that you have to draw it 1 by 1. Here's what I mean by that. So you draw 1 pointing up with a positive 1/2 magnetic or spin quantum number. Then you have to draw your second electron in the other orientation subshell, so the 2py, and then your third electron in the 2pz. Then you go back and then you draw your negative 1/2 spin quantum number electrons. All right, you do that, you follow that order, because remember, electrons, you can't put the electrons in the same subshell right away because both electrons will have a negative charge and they'll want to repel each other. So you have to spread them out first in different subshells and then put them together once the subshells are filled up. So you put 1 in each if there's multiple subshells in that same p orbital, or same orbital I should say, you put 1 in each, so pointing up, spin quantum number plus 1/2. So your electrons pointing up, 1 in each. Then once you're done, then you go ahead and put the negative 1/2 spin quantum number electrons pointing down back over in the 3 subshells, because electrons repel each other, okay? So you don't want to put 2 electrons right away when there's space in these other 2 p subshells, okay? And that rule right there where you follow it one by one, that you don't put 2 electrons in the same p subshell or the same subshell unless you have already put 1 electron each pointing up in all the other subshells. You call this rule the Hund's rule. Okay, so that's the Hund's rule. And now, so we're done with the 2p6, and next comes the 3s orbital, okay? And the 3s orbital will squeeze in right here. Notice that I'm drawing it. Let me go ahead and erase this. All right, so let's go and erase this, and I'll actually, you know what? I'll just write it up right here so we can still see the electron configuration notation for magnesium, which is going to be 1s2, 2s2, 2p6, and 3s2. All right, where's that neater? 3s2. So this is the 3s orbital, and I drew it again above the at n equals 2 energy levels, right? This is also n equals 2. This is n equals 2. Because the third energy level has more energy. So energy is energy is increasing as we go up. So let me go and squeeze this arrow in. Energy is increasing as we go up. We're going to write that down. Energy increases as we go up energy levels, okay? And so we're back to our s orbital, so we write it in this section, all right, in the same section as our other s orbitals. And as we see from electron configuration notation, magnesium has 2 electrons in the 3s orbital. So we write 2 electrons right here and 1 pointing down. Right? So positive 1/2, negative 1/2 spin quantum number. And that's it. So that's how you draw it, okay, for magnesium. And let's go ahead and use the drawing method again for iron. Okay, so let's actually go ahead and duplicate this page and do it on a separate page. All right, here we are. So iron is next. Okay, so let's go and write out the electron configuration for iron, right? The long way, unfortunately. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and we have to be careful, 3d6, all right? And again, you guys can even switch this notation up. So when you go here, you can write, because usually you're supposed to write from lowest energy level to highest energy level. So this way is also correct, but you can also switch these two around. Okay, so instead of writing 4s2, 3d6, you could write 3d6, 4s2. Okay, but either way works. Let's just go and stick with the top one. All right, let's go and erase that real quick. All right, let's go ahead and draw this. So we'll need more room because there's more, we have more orbitals to work with here. So let's go ahead and draw it all the way here. All right, this is going to be our 1s orbital. All right, let's scroll up. In our 1s orbital, what do we have? We have 2 electrons. Sweet. So let's go and write that down, or draw that down, I should say. So 1 positive 1/2 spin quantum number, and we're going to draw 1 as a negative 1/2 spin quantum number. All right, 1 pointing up and 1 pointing down. Next, let's move on to our 2s orbital. Sorry, I don't know why that's slanted. 2s orbital. Okay, so we go up. Our 2s orbital, we can see, guys, that it has 2 electrons in it, right? So because of our electron configuration notation, 2s2. So that means that we have 2 electrons in here also. All right, sweet. Let's move on to our 2p orbital. Because we're working with the 2p orbital, it's going to have slightly more energy than our 2s orbital. So we're going to draw it right here. Nope, not like that. So we have 3 different orientations for our p orbital. We have a 2px, 2py, and 2pz. Okay, and in our 2p orbital, we see we have filled all of our electrons capacity, right? The capacity is 6 electrons, 2 in each subshell, and we have 3 different subshells. So 6 electrons, which means we have to draw 2 in each. But remember, we have to follow Hund's rule here, okay, just for practice. So we draw a positive 1/2 spin quantum number electron drawn like that. Then we have to go to the next subshell orientation because we can't put it in the same one here, right? We can't put another one drawing like that because electrons repel each other. So we have to fill the other subshells first. So again like that, and then again like that, and then we have 3 more electrons left to draw, and the only other space left is to go back and put 1 electron in each subshell again. So we go ahead and do that. All right. Nope, that got bad. All right, so 1 here and 1 here. Okay, so that's 6 electrons done. Next, let's go on and fill our 3s orbital. Just notice I should draw in much more room, or made much more room, so let's go ahead and start going a little smaller so we can fit it up to the top. Okay, sorry about that dot. All right, 3s. Okay, so slightly more energy again. And in this orbital, or this energy level will have, orbital and energy level will have 2 electrons, okay? So we're in our 3rd energy level, and in our s orbital, we fit 2 electrons. So let's go and write that down, 2 electrons. Okay, 3p6. Okay, so we're back in our p orbitals. Remember, we have 3 different orientations. Okay, so we have a 3px, guys, we have a 3py, and a 3pz. Okay, again, same exact thing, Hund's rule. We know we have 6 electrons, so let's go and put 1 electron in each subshell first, and then let's go and fill the subshells up with another electron. Okay, and we have 2 more to go, so let's go ahead and push through and write those down. Okay, so our 4s orbital is going to be right here, and we have 2 electrons in our 4s orbital, so 1, 2, right, positive and negative 1/2 spin quantum numbers. And last but not least, guys, let's go and work with our 3d orbital. And remember from our quantum number videos, the d orbital has 5 different orientations, and so that means we're going to have a full capacity of fitting 10 electrons, but here we don't have 10 electrons, we only have 6 electrons here. Right, so this whole thing is our 3D orbital. Okay, so let's go and write that down. This whole thing, just go use a different color. This whole thing is our 3D orbital. Right, so 3D, and we have 6 electrons, and this is where the Hund's rule actually comes into play. So we can't put 2 electrons in the same thing. So 1 here, electron repel, let's go to another subshell, 1 here, let's go to another subshell, 1 here, and 1 here. Now you go back and then you put the last electron in the first subshell. That's Hund's rule at its finest right there, okay? So bam, right there, that's our electron, our electron configurations right there. So that's for iron. And you're probably wondering, well, where does the Aufbau Principle and the Pauli Exclusion Principle come into play? Well, the Aufbau Principle states or says this, like pretty much what Aufbau Principle says is that you have to fill your electrons from the lowest energy level up to the highest. Okay, so you can't, like, let's say we're starting at our 1s, right? So you can't like fill your 1s orbital, and let's say for right now our 2s is blank and we haven't put any electrons in there. The Aufbau Principle says you can't start here. You can't put your electrons in their lowest energy level and then like be a savage, and then let's say this is empty also, and you can't be a savage and just jump up to the highest energy level and put electrons in a higher energy level. Okay, you can't do that. You have to go from the lowest to highest. You can't jump to a higher energy level when there's an empty orbital that has a principal quantum number lower than what you're jumping to. And we have a principal quantum number of 2 right here, an energy level of 2. So you can't put your electrons in the higher energy level until you have filled the lower energy levels with electrons. So we have to fill the lower energy level electrons first, and then you go up. So we're going from low to high energy levels. And all that, what I just said, is the Aufbau Principle. Okay, so you have to go, just remember, you're filling your electrons from low to high energy levels. Right, low to high energy. Okay, so just remember that for the Aufbau Principle. So if I recover the Hund's rule, right, you have to fill your electrons in 1 by 1 in each subshell until all the subshells are full. Then you fill your second electron in back in the first subshell where you started, because electrons repel each other, right? And we have the Aufbau Principle, filling from low to high energy. That's the end of the video. Our Pauli Exclusion Principle, Hund's rule, and the Aufbau Principle. Hopefully you guys made sense, or hopefully this video made sense to you guys. I hope to see you guys in my future videos where I'll talk about more cool topics about biochem, physics, and Chem. Don't forget to like and subscribe and hit that notification bell. And see you guys later. All right, stay safe.